like YouTube changed a bit, and when you go live, you go live. You can't pause. Okay. Oops, not this. We'll be starting with this. Like YouTube changed a bit. When you go live, you go live. You can't. Don't pause. Listen to myself. It's stupid. Okay. Oops, not this. We'll be starting with this. Good. So we are live. Should stop the meeting. We are live. Welcome to the largest developer community on the planet, focused on crafting software. Yay! So we are here trying to make an art of our mess, of our practice. So I should introduce myself, but this meeting, in case you are watching it on YouTube, this is for the community that we have over here, the largest with a lot of ratings. Join us. It's very fun, and you can be in the Zoom meeting to interact with, right now, 35 and growing people chatting around all sorts of ideas. Usually it's much more fun in the meeting than in YouTube, in the Zoom meeting. Good. So let's kick it. Quickly introducing myself. My name is Victor. For 18 years, I'm coding Java. I worked in a bunch of domains. I have experience in all sorts of other banking, e-health, gambling, ad industry, transportation, telecom. I came in contact with these domains because I'm doing right now workshops for many companies around the world. So I have a lot of contact with different types of code bases, let's say. And one of these clients of mine had some really interesting code base in a domain that I am very in love with. And I had some discussions with them recently, and I wanted to share with you what I learned about how to salvage a monumental, complicated, old, 20 years old code base. What can you do if you are facing such a challenge, right? And these workshops that I do, I try to take the parts that I the monologues, and extract conference talks out of them. So if you watch my talks online, you can get a lot of stuff from my workshops, basically. So this is the community that we have in front of us here at the European Software Crafters community. Done. And I'm also trying to have a live. So this is me. Let's go. We have the following notes. I will publish these notes on the meetup after we finish. The code that I work in, a project that I will use at some point to write some rules. And all of this will be uploaded to the event page here. Good. There are some notes here that you can see afterwards. This is my cheat sheet. Let's see, where do I put them so that I can see all of you here. Perfect. Good. So let's bring some code on the screen. And let's start tackling different points one by one, following my notes. All right. Feel free to use the chat whenever we interact, ask, answer. Good. Oh, let's hit it. First point. First point is to remove some boilerplate. So we will start easy. We will start small, warm up a bit, and then we will finish with the hardcore. Remove the boilerplate. So there is boilerplate code in this project. For example, for patient, there are set ID, set first name, set last name, stuff that even IntelliJ says, hey, you could use setter here. Good. Now, well, what I can do is, of course, click here, and there is setter on the field. Fun. But if I want to fix these problems everywhere, this is probably, and this honestly was the tool my client used to clean the most of the lines. Alt enter on yellow in IntelliJ, and then you say this, you click on the three dots, only the seniors know to click the three dots, and then you have run inspection on the entire project. So everywhere where you will find a setter, boom. Now it can be replaced with IHA, right? Replace, boom. All the project is now using. Now, the advantage of using, you could say, well, Victor, I could just manually add it it's a lot of work, right? But wait, why didn't the phone number get one? So after this first round, you watch the phone number, what happens with it? And you will realize there is a bit of a glitch. If you use any other tool or manual, you could miss this point. There is a typo. The getter was manually written 15 years ago. And they mistyped it. So we can rename this all over the place, align it to what it should be, right? And now this and this, align it to what it should be, okay? All right, and then this get and set phone number, and then the set phone number, this is doable again with setter here. But just for curiosity, let's de-lombok everything back where we came from. So now we have this set phone number, might have a set, let's, 1 second, let's wait a bit to build. What happened in their case is that if all the fields if all the fields were potentially replaceable with setters, the suggestion that IntelliJ gave them was to, 1 second, let me undo everything basically from the beginning. When we do such large-scale refactoring, there will be always a sort of back and forth until everything aligns properly. So this phone number, let's correct this first, the getter and the setter. And that's what happens now. And that's exactly what they did. They've done back and forth with these suggestions until the suggestions led to, wait a second, the whole class can use the setter. Beautiful. So technically, you can do this progressively, one by one, and now you can, poof, all the class got setters. If we have getters all the place, then this can also turn into getters. So what you can do, can I replace this with, okay, but I don't see any suggestions pushing me to go there. You see, it's not yellow, basically. What you can do, go there, 3 dots, and increase, that's an intention actually. This, you have to click manually. No, I'm not happy. No, I'm not happy. I want to replace getters and setters everywhere they are with lombok. So in that case, wait a second, how could I do this? Well, one way to do it is by, yeah, technically, if the code compiles right now, if I put getter on the top of the class, and if I remove all the getters, that should do the trick. If the code everywhere still compiles, I'm pretty good. There is a dark story about using reflection. If there are parts of your old project that are using reflection to nail a certain field by name, you might get into trouble, and you have to know where these places are. So as a lesson here, if you start working on a large code base, identify the places where the clients of your methods or whatever you're touching could be. Some methods like this could have mapping into databases, into files, into all sorts of, find those before you start rippling changes all over the place. So technically this get ID over there could be replaced with lombok, could be replaced with lombok, and so on and so on. You might actually do this manually at first. Now let's do this for start manually. Again, this get consultations, lombok, get process center ID, lombok. What are we end up with? What did we end up with? We ended up with getter. So if you see all the fields are, you can just take this up one level, and there you go. So in their case, one of the problems they were looking at is a lot of boilerplate, a lot of craft. Their actual logic was hidden all in a bunch of useless code. Equals hash code. Okay, there is an equals hash. And they told me, Victor, we want to use data. That's how they came to me. Victor, we want to use data because we are big fans and we saw how cool this looks. And in the discussions we had, they said, let's use lombok. Let's just put lombok data on the class. And I told them, no, there is a danger in here. If you're putting data on the class, the code that gets generated would include hash code equals and toString. And so what, they said? Well, look carefully. In your equals, you include ID, first name, last name, phone number, email, but there is no consultations. If you put data on the top from lombok, that data is gonna be generating hash code and equals. So if you plan to remove these, you're going to be in deep problems because now hash code equals include this. So you can easily, when you do these changes, the first thing you have to care not to break the functionality. Huh? So if you put data, the hash code and equals, be sure to know what it generates. As a check would be to de-lombok the class to see what code was generated for you because of this lombok data. And now you can find here also consultations part of the equals and hash code. So the first law is don't break things. So take it baby steps and automate only when you see when IntelliJ tells you, hey, you know, this is the same thing. Usually when there is an inspection pointing about something, very, 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 very rarely it happens that it breaks the functionality. So getter, setter, and data. We did that. Also, they came to me with some simple things as well. This was not simple. This was hiding some of the bytecode underneath this annotation processor. It's debatable. It's tricky. Something much simpler. This consultation is grayed out, saying, hey, this is useless. So let's, hey, not Thailand, Nigeria. Buenos Aires, saludos. Consultation is gray, can replace with a diamond operator. Nice, IntelliJ, yes. You can do this all over the place. Run inspection on the whole project, done. Test as well, go. Right? Java records is a much more difficult, it's a much more delicate discussion. Java records would make all these things immutable. So you had setters. Now, I am salvaging, migrating some terrible monumental code base in a very critical domain. Yeah, I can't go there and do that. Email equals null. And literally, this is samples of code I found. Like, hey, why would you equal to null? One reason would be to have multiple constructors, and some might not do this. Let's give it a try. What if there is another constructor? What if the other constructor, it's still, no, I'm wrong. I'm setting to null. If I don't set to null, it remains default, null, done. So this could be run on the entire project, all the files, done. Where is it? Wait a second. I don't have the suggestion. I need to Alt-Enter on each. This is an inspection. Good. And what does it suggest to do? Move assignment to field declaration. Okay. So this was the, I should do this, fix all. And it doesn't. I want to do it on the entire project. Can I do it? Project, please. Yes. But I do not have the button to kill it everywhere. So in this case, I need to go each and every place, move assignment to field declaration, boom. Or even so, even worse, I don't need it at all. So if a field is set to null in a constructor, that could be, let's not go too far with this. Let's keep it simple right now. Alt enter and then move declaration to, and then again here equals to null is redundant. Remove initializer wherever it's not used. Cool. So again, syntax-based transformation. I'm not taking any chances to get things wrong. But let's do this mistake. Let's try to remove this annotation wherever it's present. It's some legacy annotation they had and they wanted to remove it. Now, if you have any Linux fan in the team, they would think of using some grep. Let's use regex. Let's use regex. Life is not good enough if I don't use regex. So let's use this and replace this with nothing. But if you do this, you just missed this one. I know. So roll the annotation and let's try to open a parenthesis, but I have to open with an escape character. And then type, and then you leave the guy banging regex, go have a coffee, you return and the guy is still not there because he realized there is this also. Why would someone do that? Right? So you would like to kill the annotation wherever it is with whatever parameters or not. Of course, you could go and say, click the annotation, destroy it, fix the compilation errors. That could also work. But you have to go through hundreds of places. It's a bit, right? So can we do this smarter? Let's see. What if I go and say, is it the time now? No, I want to go now in there. Let's hold this for later a bit. I have something easier to show you first. There were a lot of messages of places in their code in which there were implementing, for example, medic implements a mysterious method from XML. Don't ask. Which takes a document, don't ask. It helped. And this was because they had to implement an interface. Any thoughts from your side? What could I do to not pollute the code everywhere with something that used to be? They were planning to kill this completely, to remove it. It was no longer relevant, but they could big bang because it was everywhere. And there were 3 corner cases in which that was still being used. What can I do to remove this boilerplate from here? Anyone? Let's stick with the patient. Where is the chat? Default method on the interface, exactly. So from XML, what does it do by default? Nothing. Perfect. Done. Document to XML. What does it do by default? None. Perfect. Return none. Done. What next? Well, next you have to kill this. Oh, they turned yellow. Perfect. It's identical to its super method. Alt enter, remove redundant method in the entire project. In the entire project. Wait a second. I wanted in the entire project. In the entire project. Done. Analyze everywhere. Remove. Done. In that case, 1,000 lines of code less. Yes. Feels like a god, huh? All right. So then one more thing, which starts to get a bit darker slowly. There is so this also should be moved to field declaration. Boom. As a general idea in clean code, I would not accept code which initializes a collection anywhere else but in the field declaration. I want to make sure that the collection is never left null. Right? And then the constructor becomes, yes, thank you. Good. Boom. Now, we're kind of done with this. We contracted to the minimum we could without breaking functionality. All right, good. The string is the same as custom, right? But I have this problem in the patient service. Patient service, was it? Let's try medic. This setter in this field takes array list. So I have a field taking array list. That's going to stop me from using Guava. Immutable list. Unmodifiable list. I'm dreaming, Eric. But in a sense, it's going to stop me from. So could I replace all the fields everywhere to accept list? Wow. Let's start with the most simple, clear one. Guys, if a method accepts array list, there's nothing that can go wrong if you just accept a list instead. Okay? You make the parameter, let's say more. Actually, but then how do I put it in the field? Let's just say we attack the fields first. How do we attack the fields? Well, let's play this game. I'm going to take this, and let's suppose there are multiple such things. Let's say list 2, and there is another thing like this in the patient. Let's make this array list, just for fun. Put another one. Yes. Not this. Come on, where are you? This, go there. So I want to take this syntax and say, you know what? I want to create a view, replace structurally. And now the power tools come to play. Add what you know until what you saw until here is just warm up. Now, let's say this, right? This, what would this match? It matches fields called consultation of type array list of. Could I say anything? You could. But I'm still, so when it turns blue, it means it matches that. So anything you would give here, as long as the collection is called consultations, would match. Okay. But I don't want just this name. This should be just some list name. So array list of anything. Okay. Private array list of anything. But this T, not correct. This is a variable T. And suddenly I have more stuff matched. Private array list T. So I'm a bit concerned about this going green. Let's see. Array list of T gets replaced with what? With list of T. Let's try this once. So find. It found this, and this. Replace all. Replace all. Poof. List, done. No more. And of course, this could have been, you could put an enter here, they could be annotated or not. And if anywhere now, we have a private collection. Now it takes, we could do the same technique here, honestly. Or here, we could have set anything, put a a placeholder and returning void public, taking array. But this is just a getter and a setter, so this should have been solved previously with the previous solution. So honestly, we didn't play it correctly. I should have. And another lesson, I did it in three clients. I've participated in the refactoring of a class of 35,000 lines of code. So the first attempt at this class is just to find your way, and then you will order the refactoring moves in a certain sequence that will get you best results. I should have done the getter refactoring first, right? And setter. By the way, getter for these two, is there a getter and setter? For the name, there wasn't. Okay. Okay. All right. And this again has to be moved. Have to be moved into the annotation, and then the same thing. Good. So this was replacing the type with the generical list type. Now let's go on and kill the annotation again, but with the tool we discovered. Replace structurally. Oops, not this. Where am I? Here, back. I'm here. So old annotation. Let's try again. Replace structurally. So, yes, I want to match with my search this and this. How could I do that? Let's try. Anything? But this property name maybe should be optional. Technically, you could run multiple. You could run multiple replaces, one with parameter name, one without. How many combinations could there be? And you replace with what? With nothing. And to match anything here, right? Anything. Any string, basically. It goes by the syntax and it matches this. And if you find, it matches the consultation field annotation called this and this. Done. Replace all, done. Yeah, good. I have other better things to show you. Then another thing is methods that are called, they said, that are only called internally inside the same class. We want to make them private, not public. If it's an internal method, we don't want that. So Alt Enter again. And the thing is, you might, let's be honest, if you try this on your own project, it will not show up. It's like this. So if something annoys you, the first thing I will try, Alt Enter on the thing that annoys me, and I will see if there is any suggestion. There isn't, right? So what could you do? Well, technically, honestly, I would have to go to inspections and look through these 700 inspections in Java to see whether you find what you want to do. So I cheated a bit in advance and I said, can be weaker. If you just enable this inspection, I will show you here in the settings paste, can be weaker. This thing over here, you can tweak it. By default, it will not show up. In most editors, it doesn't show up in IntelliJ. So what you do, you say in production, if you ever find a method that can be, whose visibility can be narrowed down, guys, this is a one-shot refactoring, attempting a refactor of thousands, millions of, hundreds of thousands of lines of code. Right? You do it once, you're done. The main concern is not to break stuff because you're going to change code everywhere. So if you have the slightest hesitation on whether this breaks anything, stop, you don't do it. But I want to show you one trick here. When you do this run inspection on the entire project, you can choose what packages. And you might discover that there are some places that you shouldn't touch code because even private methods are called by some dark framework. Shouldn't be the case, goddammit, but who knows? But this used to be a public method. So maybe some framework scans these methods and it does something about them. In that case, you avoid that part and you create custom scopes that will limit your changes to the part that you know it's safe. So compared to what we're going to see later with continuous refactoring, this step of salvaging a project, look how many places, right? Except carefully look in what parts maybe public going private breaks stuff. There could be DTOs exposed, map from files, from XMLs to all sorts of technologies. I don't know, maybe in libraries, but you don't see their clients. Be very careful when you do these changes, of course. Good. So we went far. We've done this. Now, good. There is this also. This is a bit more interesting. There is code which is marked for deprecation. Apparently, you shouldn't do new long of string since Java 9. Okay, so how can I get rid of this? Well, wherever this appears, and let's, for fun, duplicate this once and put it somewhere else. Wherever this appears, mapping some string as a number, and then you can take this part, or just this part. Let's start atomic. The smaller code you select, the more occurrences, right? So this, again, with my tool, replace structurally. And you say anything here, but that thing over here should be a string. Or if it's Java long, string. Now, when I do that, I should have another example in my game here, which does not match. So let's do the same thing for a number. Can I do this? Yes. That also is marked for deprecation, but for now, let's just assume that I want to restrict to only the string. You see, the other is not anymore green. So the match, by the way, I have to say, in dark mode, the highlight looks like crap. Anyway, the point is, this is now of type string. Cool. So I can say, and what should I do instead? Well, probably long.parseInt. Parse long of the same ID. Good. String OP doesn't work. Exactly. String OP doesn't work. Oh, by the way, someone just put in, I know, just saw in the chat, no more AI required. Oh my God. Using AI hallucinations to do refactorings in production in legacy code bases? Never. Never. So this is just a dream, guys. Right? Even Juni can do, even AI agents can do shit. So, find, it matches two places, should be. Boom, boom. Right? And then these two, the strings, replace. I'm left with the one with the in because I didn't pick it up. Huh? So it's a parse long, but wait. Wrong, me wrong. This is not parse long, undo. It's value of, I think. So replace structurally. It's recent. I'm wrong. It's value of that I want to use to keep things identical and do the slightest minimum. This approach is actually the philosophy of IntelliJ refactorings as well. Do the atomic changes first, and now that you have this, you can run this wherever possible. So you cascade the changes one by one. Okay? Long value over 42, you can then do parse long. So cascading from simple to simple refactorings. So technically, you have to first pick what we did with the client. We had to pick, first of all the examples possible that we want to replace, and then for each, appearing each hundreds of places, what to do, how to get away from it. This is a nice log debug with plus. This should be highlighted for every one of your editors. Replace with parameterized to avoid to stringing the object. So that, again, is a good practice to do anywhere possible in the entire project. Done. Replace constant. So this everywhere. Done. We are kind of done with this. Oh, there's a dark story. There's a dark story. This will be the most complicated example I will show you with restructure replace. They wanted to move to Spring. And there was a patient service over here that was already managed by Spring, but it was creating the data access object by new in an init. Don't ask, it's a dark story, but they had a parent service that wanted to keep track of the DAO that you're using. So instead of this, brutally take the text, you say replace structurally, and then you say, whenever you find this, instead, let's see if I can do this, please replace with an auto-wired, which the patient DAO was already in the context, takes the patient DAO as a parameter, let's call it inject, DAO, and calls superclass with DAO. This still matches the code, but I didn't generalize it yet. So patient DAO is just a DAO. And you can set here modifiers about what type to have this DAO thing. You could say it should be on that of that type, super types, and so on. New DAO, and public void. If I'm lucky, this should do the trick. find, replace one, done. So now Spring picks this up, injects, done. That was the easy part of migrating to Spring. And many legacy code bases would benefit enormously from dependency injection and thread locals. Right? What? What was that? Guys, if you are in a DAO and you need the username currently executing the flow, traditionally we had to take this as a parameter through all the method signatures to pass it through the layers until the DAO to know to write it down in some database, insert, update. Now, what they did already, what they already had in play was a bit of a, so they started migrating the code, but they wanted to finish the migration basically. They created a user holder, which in a thread local stores the current user so that you don't have to pass it through the layers. You can magically pop it out of the, wherever you need it. And I've seen this in 2 clients of mine. So technically, if you are in this method and you've come on a path that sets on the thread local the necessary metadata, you could take it from over there right here. So look, you can say user equals user holder dot get current user, done. And you got it from a static method which takes it from a thread local. I'm not going to explain what thread local is, but they are heavily used by frameworks today in backend. User, and now the user becomes unused. So you could alt enter remove this variable, right? And then you can kill the parameter upstream wherever it was not used. Okay, that's no longer a matter of how fast can I move, but how safe can I move? And there is the following problem they ran into. And I can think, if I'm lucky, I could actually demonstrate this to you. Let's see. They've done exactly this. Let's do it both places. I hope I didn't break everything in the meantime. Here. So user equals user this, and then this. So they've done these changes, right? They run the application. Start. Then they got a null pointer exception. What the heck? So they said patient DAO update here, the update function here seems to be used. Oh, again, what the heck is this? So they've took the user from a thread local. But when you do this, what you must do is to make sure that all the execution paths that lead to this place have set previously the thread local on the current thread. So what you need to do is, one of your good friends in refactoring legacy is call hierarchy. You click on a method, you see all the editors have this call hierarchy, and they show you where this method is called. And now we realize that this is called by a scheduled. And this scheduled did not set anything on thread local. The other flows that I had in play, the HTTP flows, right? The other flows that I had in play went through a filter that have set on the thread local the necessary information. This is the tools of the gods over here. You've gone through some filter HTTP that set something on the thread local. So when you went to repository, you got this back. So you see, when you do filter, when any HTTP request comes into your application, you set the user on the user holder. You set it in the thread local, so you can find it back in the repository. But on that path coming from the scheduler or from the SOAP endpoint or from the Kafka listener, ActiveMQ, whatever you have in-house, those flows did not have the thread local set. Dark story. One solution we found with this client was, whenever you think you have this set on the current thread, but the worry is, how can I be sure that coming in this method on the thread has previously being set a thread local? How do I do that? Well, technically, in a large code base like they had, they couldn't track all the possible flows. It was way too much. So what we did instead, we did this. We created another method in the user holder, and we said, I will pass you the user I already got through the parameters, and if the concept is the following: if the current user, the thread local variable, get is null, then I will default and return to the user that I already got for your parameters, right? If it's null. Otherwise, if it's not null, I will get it to you. So that's actually, it's more natural to put it backward. Huh? So if it's not null, I will give it to you. If it's null, I will default to your parameter. And then we did this. We did log.warning. And we said, we should have had here a user on the thread. Where here? Here. So basically what we just did, we logged an exception on the place where
Victor,
yes,
it just said the recording stopped. I'm not sure if
yeah,
it's,
someone started that the YouTube live stream is still going on. No worries. Yeah. So this random exception over here that I'm passing as a parameter is going to be logged as a stack trace, showing me where this showing the place in the code. If this pollutes the log too much, there is another dark story with GFR events. I don't have this prepared, but you can log a GFR event. Log a GFR event with 0.01%, I'm kidding, performance impact. And they are not visible in logs. You can take the GFR recording and see where the stack trace of this occurred. If you want to save the log space and the performance of the dark stories, guys. The dark stories. So technically, the plan was, if we put this to production for several months and there is no such warning or event fired, it means that all the flows. Not perfect, huh? This is not syntax. This is empirical. Let's just, what are the chances? We've been calling thousands and thousands of places. So we are almost certain, huh? It's not science anymore, it's engineering, unfortunately. Right. Two more things to show you, to go to the topic that Rick will pick up from. I have to show you, first of all, something that has literally changed, that has done the biggest, has changed the biggest number of lines in their project. It's called OpenRewrite. It's technically a tool to do automatic syntax-based transformation of existing code. And I'm using here one of the famous recipes. It's called AssertJ recipe. If you just copy paste this file into your project, and if you have IntelliJ, you can run it. It will move your assertions to AssertJ and upgrade the style of your unit tests to the best possible. So making public, private, collecting unit only tests. It's a perfect place to start to gaining confidence in OpenRewrite because it will only target your tests. So you do this. It might take a while. For them, it took 3 hours to run. 3 hours. 3 hours to run. It changed hundreds of thousands of lines of code. Right? But the fact is, they've deployed it to production, no problem. First of all, this is only tests targeting, right? But I will show you another one, which does a lot of cleanup or all sorts. Let's see how much code did just changed with this rewrite. For example, tests, to get a feeling of what has changed. Here, not much. Let's try more. It removed the private on some tests. Let's see this. It turned is equal to 1 into is 1, is 0, more meaningful. All right. Let's see here. I have one which should have broken into pieces. I'm already using assert that. That's why I didn't do that much damage. Here, it moved assert equals to assert that has size, assert that has size, assert that has size. Fun. So with one go, you upgrade all the code. And this is a recipe that is used by many projects. Many of my clients are already using OpenRewrite for various Spring Boot migration 2 to 3 or Java 11 to 17. There are a bunch of such already available. I'm going to commit this, OpenRewrite, and I'm going to run one more recipe for you, the commons one, which fixes kind of like the sonar issues in a sense. The commons, kind of like sonar issues. See? And in the meantime, I want to dare to write a So the idea is that this OpenRewrite is this recipe is manipulating the abstract syntax tree, but manipulating the syntax tree requires some very advanced coding skills, which most of us don't have. And I don't want to be that deep into syntax trees. Look, what just happened randomly. The parentheses were now they put braces to the if statements. Let's see what else. They use here method references. The same here. They've parentheses again. What's happening here? I don't see really. Please variable parentheses again. Private final, since this was never reassigned, final could be set. Why not? So this is the most important thing is this is safe enough. This is safe equals 0 is empty. Okay. So let's say sonar style. So now let's move to the next part in which I want to write. I should actually give the floor to. Can I steal 5 of your minutes?
Of course.
So actually, I don't need that much. I just wrote this code. So swear to God that I've cloned this project tonight at noon, and in 40 minutes, I have this demo for you. So it's super simple. All the code I wrote, it's here, very, very simple. The 2 files I'm going to show you. What do we have here? Let's see. So first of all, let's start with the recipe here. Sorry, not the recipe. This, technically speaking, is a refaster template. It says before template. So if you encounter anywhere a string builder append of a string that is first substringed to be split and took part of it, it makes no sense because string builder has a dedicated method exactly for this, which picks from a car sequence an amount of characters between start and end. So even IntelliJ here says with inspections, hey, you could just do this. IntelliJ knows, but how can I make this, automate this on a pipeline, or how can I run this out of the box in a list of recipes on a project by just drag and drop it, by just putting some YAML file like I showed you here, run it, and ta-da. How can I do this? Well, I write such code. So before template means the code that we find there, any from any to, I don't care. I replace this with this code instead. How does the test look like? This is, to me, absolutely super clean. You say, this is an example of a test which does string builder append of a string substring. This should come out. Let's try to have another test. So this time I'm going to say, I think I put, is it correct? I've closed this. Oh, it's green because IntelliJ doesn't figure out that this is Java code. Done. So let's suppose that this would be a literal string. This is a bit forced, but why not? This should result in this. Run. So all you have to write, technically speaking, is the code you don't like to see and the code you want to see. You can use parameters in the first, and you can use the same parameters in the second, in the after template, to rebuild the code the way you like it. Again, there is no manipulation of any syntax tree. Under the hood, I was curious to see what this was generating under the hood, and this is bytecode. Huh? If you look into what code you should have been written with OpenRewrite, this is monumental. I don't think I want to learn this tomorrow morning. Right? But this is super juicy. All the code you write is here. And because I am not the expert in this Refaster Rules, I will let Rick take over from over here. I just wanted to show you how easy it is to just create a recipe like the one I just ran here. So I got basically a recipe, just like this was technically a list of such recipes. What I just ended up with right now is another recipes of my own. So I could grab this class, put it in my class path, run it with YAML file, done. So I don't want to steal more. I will give the floor to Rick, a friend of mine that is very deep into this Refaster, but I will let him introduce himself. So I will stop my sharing. And please, the stage is yours.
I think you're seeing my screen.
Yes.
Nice. Well, thanks, Victor. A very nice introduction. My name is Rick Ossendrijver. I work for Picnic, an online supermarket based in the Netherlands. And me specifically, I'm a lot into static analysis tools. So I work a lot on error-prone support, and also did a lot with OpenRewrite. The cool thing is that, well, the Refaster rules that Victor just showed, we have a lot of those that we open source from within Picnic. So we created a lot of these Refaster rules. We had also have a testing framework and all that. And well, after we open sourced Tim Tebeek from Modern, the company behind OpenRewrite, I saw him quite a few times at conferences, and at some point we started talking about, hey, this is actually, yeah, maybe we can do something such that we can also run the Refaster rules and have the easy way of specifying these refactorings and run them on a large scale, as Victor just showed. On like, yeah, you can simply run it on a very large code base, and it might take a while with OpenRewrite, but at least you have your whole code base rewritten. And that's actually quite cool. So yeah, at some point we started to look into this, how it would work, how Refaster could be able to work in OpenRewrite. And you just saw the IntelliJ best practices recipe, which actually is a list of all these recipes. And funny thing to show you is that this also uses our Refaster rules under the hood. And yeah, I'm going to show you a bit how this integration works and how this nice collaboration came to be. But first, a little bit more about our project. So yes, we open source this project error-prone support, which has some extensions to error-prone. Error-prone is basically the tool is an open source tool from Google that is yeah, originally the way in which you can run Refaster rules on your project. But I would say there are two important differences, because right now we saw mostly how to run one-off migrations on a whole project. But actually at Picnic, we are using a slightly different approach. We want to have continuous feedback on every time you write code and you open a pull request, that we want to get feedback on, hey, you introduce a new violation on this test method can actually be a better assertion, for example. So what we did is we actually, yeah, we are using error-prone. So we use error-prone for specific checks, but also for to run Refaster on our builds. And I'm going to show you a bit how that works for us as well. So yeah, I'm going to show you the error-prone support project, and we're going to write a very simple rule. Well, let's say a very simple rule for the string equals would be, hey, we want to have a before template, and we want to simply get rid of all the string equals, and we want to rewrite that to the string.isEmpty. And as you can see, our my code pilot will already help me a little bit, so I don't need to completely write it out, which makes it quite easy. Although this is then already an IntelliJ inspection, as Victor showed us. What we can now do is, if we build the project and we would hook these rules into our build, then we can configure error-prone to actually run on every build, just like when we do a Maven clean install, that it would simply work. As for this project, well, I think you already saw a few Refaster rules, so I think we, yeah, maybe just to give a feeling of how easy it is, let's implement another one. But I have the test cases here on the right with a slightly different testing structure than OpenRewrite, but it still gets the job done. So what you can see here is that we have how we do it in error-prone support is that you have a Refaster rule, and we write some violating code, just like we saw in the OpenRewrite side, which is then right here. So we have, hey, we want to have the empty equals, and then we specify in the output file how it should look like after the code has been rewritten. Same as with the OpenRewrite. So that's on the right here. And the same cool thing is if we want to rewrite an assertion, because, well, assert that file.exist is true. If we can use the by IntelliJ provided exist, that is of course a lot nicer. So if we want to do the same, there are a few more interesting typings going on here with the IntelliJ I'd say subclasses, but so if we would run the test, then we would see that this simple assertion, new file foo exists, is true, would be rewritten to this. So again, very simple example, but why I'm showing you this is that because if there are many of these rules that you have, so for example, let me show you a few examples we have. So this is the documentation website of error-prone support, and here you can have some documentation on all the rules that we have to see why we actually want to rewrite those. And maybe even nicer to show you is this. So I have a very simple demo project where if there are a few violations and how it would work with error-prone, and this is then an important difference with OpenRewrite, is that if we would simply run our yes. So we say, hey, Maven package -p error-prone. So we run error-prone. You can, of course, also enable this by default. But what it does, it shows you these warnings in the build. So it says like, hey, there's a string.isEmpty refaster rule on line 21. Well, indeed, there is here a string.length equals 0, and it already suggests, did you mean to write string.isEmpty? There are also some other checks, which are then not refaster rules, but just to give you an idea. Here it says like, hey, on line 17, you're doing an identity conversion because we have an immutable set. And then in the rule, in the line below, we again do a copy of an immutable set. That's not really convenient. So the nice thing about this is that it gives you a warning, and it explains what it is. It gives you a suggestion, but you can also see some documentation about this. So yes, and it's a bit big maybe, but the idea is that here it shows you what kind of violations it is rewriting, and also gives some explanation as to why we are doing this. So for new developers joining the company, they will quite often see these. They have to like learn a bit the code style that you have that we have as a company. So they will get the feedback from these warnings, and they can also learn about why we're doing certain things the way we're doing them. Yes, but then the nice thing is that, of course, we don't really want to apply these changes ourselves. So we can simply say, yo, all error prone, all the warnings that you find, please automatically fix them for us. And you can see that now, indeed, this is rewritten to the length, to .isEmpty, and that this is also rewritten. And then you might see that you might spot that IntelliJ says like, hey, this one is redundant. Well, there is another check that we have for that. So one thing about error prone in comparison to OpenRewrite is that OpenRewrite builds up such a large model of your whole code base that can apply all these transformations in one go. But with error prone, it works slightly different. It's on a per compilation unit basis. So every time it analyzes one source file, and then it sees like, hey, I can make this transformation. It applies that, but then it needs to recompile that. But now if we run it again, we see that, hey, it's nicely in line right now. So how we set this up within Picnic is the following. That was in, for example, yes. Yeah, also for my demo project would also work. So how we set it up. So as I just briefly mentioned, error prone is a compile time static analysis tool. So when your code is being compiled, right after the compilation is done, error prone kicks in and then can do its thorough analysis of the code. So how you would do that is you have to tweak the annotation processor path. So we have to override some parts of the Maven compiler plugin. And what we basically do is we say, hey, please add these things. So the error prone itself, then our rules and refaster rules, and then in this case, the refaster runner. And then the idea is that you can basically tweak error prone just how you want it to behave. When you want to start introducing it, you don't want to have all the errors in one go. So what you can do is you can say, hey, this is it to just simply enable. I here have configured it to show almost all warnings, but there are some simple flags on the error prone website where you can simply say, hey, I want to disable everything, and then selectively start enabling checks and then they will, every time when you run the build, they will be checked for you, and you will get warnings for them. Yeah, so that's it for the configuration. I have some links that I will also send in at the end. But the thing is, this is for a Maven setup, but in this demo project, I also have a link to the Gradle variant where there's also very nicely explained how you can add this to your Gradle build. Yeah, so that is it for the configuration. Let's see where we are. All right. So yes, what I wanted to show you is that we have this configured for Picnic to basically on your build. Our builds are being run in TeamCity, but if there's a violation, I on purpose introduced a violation here. It will fill the build, and in the warnings it will say, "Hey." Yeah, I simply added the word test here in front of this method to show you. And it will show like, hey, there's a JUnit method declaration that can likely be improved. And now this will show me an error. And what the workflow for someone at Picnic would be is you go back to your branch, you simply run a patch script that we have, which basically runs error prone till there are no further changes introduced. So it's simply one script and then till there are no changes. I also included this in the link in the list of links, but here there are some command line flags to easily tweak the behavior of which error-prone checks you would like to enable. So yeah, that's that part. Then a little bit about the actual integration of Refaster into OpenRewrite. So what the guys at OpenRewrite did, is that they created this open source repository. Actually, most of the OpenRewrite code is open source. But they have this rewrite templating. And basically what that does is they wrote an annotation processor that simply that we can hook into our error-prone support. Let me show you. Yeah, so we simply there are a few extra things. Yeah, so we include their BOM and their BOM, and then what we do is, well, we also put their annotation processor on the class path, and basically what that thing does, it looks into our project when compiling, and simply from all, just an example, from all the Refaster rules that we have, it simply gets, hey, give me all the Refaster rules, and based on that, it creates this whole big it basically creates similar recipes as Victor showed you in the beginning of all the rules that we have. And what we do with error-prone support is we run this, and on every release we basically also ship all the recipes that we have. So that's very cool because yeah, the guys from OpenRewrite, they also open pull requests on our side to introduce new Refaster rules so that we can use them. But when we do a release or a snapshot release, then they also get these rules for free. So that's a very cool collaboration. Yeah, and I think that was mostly what I wanted to tell you guys and show you guys.
Wonderful, wonderful. So that's a very nice continuation. So we have a monolithical monster. You take it first with in the editor, slightly changing things. To be honest, if I can resume the share, what I did in the beginning, now that we know these tools, it's kind of silly. I mean, I went to do changes that I'm sure there is a Refaster rules or to automatically fix, or a OpenRewrite rule to automatically fix. But the thing is, every company has their own legacy. Maybe some custom maybe some custom framework that was built 10 years ago, 20 years ago, and you want to get rid of. Maybe some custom, I don't know, particularities of your own domain. And you can go further than the standard. What I wanted to point out today is that in 20 minutes, I was able to actually build an OpenRewrite recipe I could run on any random code base. Up to my own, I could import my own classes and build that. I will paste the link to the project that I took 20 minutes to very easy to set it up. So Rick is biased because he's working on that, but I testify it was super easy to get it running. And then once you get there is also psychology of the legacy system that makes people a bit, I don't know, it's a dark scenario, it's a dark feeling that code never seems to get to improve with simple, tiny, little changes. One little change every sprint, you can start introducing a movement of improvement, of continuous improvement. So it's about psychology a lot of time in legacy. Besides the fear, the habit, the Stockholm syndrome that we are stuck with this and will never escape. We can, with small little steps. I tell you that that company I mentioned, they did a lot of refactorings and they are very happy with the outcome. And people started saying, "Hey, things started moving. Wow, nice. Oh, Spring. Wow, no more parameters for users." There are some dark stories that I've covered. So a bit of summary, right? You can do regular expressions, but don't. You could do structural replace to get a feeling, a taste of it, or you could align with what the community is pushing towards, with Rick and OpenRewrite and everyone, with these syntax tools that are open source. You can add your own, contribute and pull and suggest more. Why not pull request your own ideas, right? When you want to adopt a larger framework, be careful about thread locals. This is always a problem. Threads, transactions, security contexts, metadata of the request, open telemetry information. Threads are always a nexus of complexity when you move into Spring or any framework for that matter. And generally just keep pushing every sprint. Keep pushing every sprint with small, tiny changes until you have everyone on board improving code base everywhere and with syntax-based tools. Nice. I think that kind of concludes what I wanted to showcase and to encourage improve. If there are any, I don't know, question ideas, there was a question that I'm not sure how to answer. PMD versus error prone. PMD. I don't know. PMD just cries, doesn't fix. Huh?
Yeah, I think so.
The sonar, it's an older sonar. Right? So if you want to cry together with PMD and sonar, yes, you could. It's about.
Yeah. The thing is indeed about the automated fixes, yeah. That's a strong point.
Okay. Okay. So, couple of seconds, perhaps some questions pop up. Yeah. If not, well, that will conclude. I thank you very much for your attention. PMD just tells you what you're wrong. Exactly, Peter.
Yeah.
Or sonar, the same. So you want to have tiny little improvements. That's the thing. Based on syntax, tiny safe changes that will prove you and everyone that things are moving forward. Huh? Yes, I will share all these documents and I will, Rick, if you can send me by email the links you wanted to share, I will
sure.
put them in this and I will put this file on the community. Good. Thank you very much. And yeah, see you, I hope, next month. Or if you happen to be at DevOps Belgium, I'm gonna be there shooting some
I'll
talks.
see you there for sure.
Yeah, catch up with you. Thank you, everyone. See you next time. Good. Bye.